Hello everyone, welcome to my YouTube channel. So in this video we are going to be talking about tree traversals, which is a key concept in programming and data structures. First we are going to be talking about what is a tree traversals, then the two common types of tree traversals, which is depth first traversal and the three types of the depth first traversal, which is Inorder, Preorder, Postorder. After that we are going to be moving into breadth first traversal, which is also known as level loaded traversal. In that we are going to be talking about how we can do the breadth first traversal using a queue. After that we are going to be moving into recursive versus iterative approach, which is going to be done using Inorder traversal with a Java code. Then after that I'm going to give you a brief explanation on applications of different traversal techniques where we using them. Then after that we are going to be doing a Java code implementation on these DFS traversal methods. So first we are going to be moving into what is a tree traversal. So now we are going to be talking about what is a tree traversal. In this video we are going to be focusing on binary trees, where each node has up to 2 children. So what is a tree traversal? A tree traversal is the process of traveling to each node in a tree exactly once. There are ways to do that, which are the depth first traversal and the breadth first traversal. First, we will be focusing on what is a node. A node is a primary component in tree data structure, which contains a data part and a connection. So here in this simple binary tree data structure, there are several nodes, which is a root node, a parent node and a children node. So first, what is the root node in this tree data structure? The root node is A. Why? Because it is at the topmost position in this data structure and it has no parent nodes. So where this is going to be the starting point for this tree data structure. And after that we are going to be talking about parent node. Parent node is the node which contains children nodes. So here for this A, B and C are the children nodes. So this is a parent node also. So this is a parent root node and a parent node. And also you can see B, it also has children nodes for it, which is D and E. So B is also a parent node. And after that the children's D, E. See here you can see D and E does not contains any children's for it. So these are at the lowest level and these are called the leaf nodes. And C also, it doesn't contain any children's for that node. So C is also going to be a leaf node. So these are the components that is going to be in the tree data structure. So here this is a binary tree where each node contains up to 2 children, no more than 2 children. So then we are going to be moving into depth first traversal and the three types of it. So now we are going to be talking about depth first traversal. So in this, the depth first traversal, the algorithm goes as deep as possible along one branch before backtracking. So first it will start from the root node, then it will traverse as deep as possible along left subtree first, then move on to the right. So there are 3 ways, which is in order traversal, pre-order traversal, post-order traversal. First we will look at in-order traversal and how it will traverse this tree. Then move on to pre-order and post-order. So first, in-order traversal. First, it will traverse to the left side, then go to node, then move to right subtree. So here I will write the traversing method here in the board. So first left subtree, then go to node, then the right subtree. So first, starting from left, B. B also has a left child D, then D also has a left child H. So the first in this in-order traversal is going to be H. Then after that, go to node of it, which is D. So after that, the right child I. Then that subtree has been completed. Then we can move to the node of that child, that subtree, which is B. Then after that, the right child, which is E. So the whole of left subtree has been completed. Then we can move to the node again, which is A. Then after that, move to the right subtree. In the right subtree also, first go to the left subtree of this C, which is J. In this J, here it has no right child. It has no left child. It only has a right child. So first we will be writing the node J. Then after that, the right child K. If there was a left child here, first we have to write that, then the node, then the right child. So the left subtree of this C has been completed. We are going to move to node, this node C. Then after that, the right child, which is L. So that is the in-order traversal, the method of traversing this tree. So after that, pre-order traversal. In this, first we are going to visit the node, then go to left subtree, then go to right subtree. So in the same tree diagram, we will be looking at how the traversal is going to be done. So first the node, then the left subtree, then the right subtree. So in this, the node is first A. We are going to be writing A. Then go to left side. The left side node is B here. Then in that, the left side, the node is D, and the D, the left child, it is H. And after writing the left child, we are going to move to the right child, which is I. So that subtree is done. Moving to this subtree, node has been written. Then the right child, which is E. Then after that, move into the right subtree. The first node is C. C has a left child. In this left child, it is the node of K, right child. So we are going to write J, first J. There are no left child. Then the right child is K. After that, C's right child L. So here A, B, D, H, I, E, C, J, K, L. So here you can see all the nodes in this tree have been traversed in both in-order and pre-order traversal. Just the order has been changed. So after that, the post-order traversal. In that, this is also going to traverse all the nodes in this tree diagram. Just the order is going to be changed. In this, first the left subtree, then the right, then the node. So you will see how this same tree is going to be traversed using Postorder traversal. So left, the node of A, left subtree is B. We are going to move in B. B's left child has D. D has a left child which is H. So we are going to be starting with H. And after that, before writing the node, we are going to move to the right child which is I. Then the node, that subtree is done. Move to the right, move to the right child of B which is E. Then the node B. Then after that, before moving to the root node, we are going to move to the right subtree. In that, here for C, there is a left child J, and in this left child, it has a right child which is K. So before writing J, we are going to write K. Since this has no left child, first we are going to write the right child, then move to the node. It is going to be K, then the node J, then after that the right child of C which is L, then finally the node C. Then after completing the left subtree and the right subtree, going to write the root node which is A. Here you can see in this board all three types, all the nodes in this tree are traversed, just the order has been changed. So that is depth first traversal. So after that, we are going to be moving into breadth first traversal. So now we are going to be looking at breadth first traversal, also known as level loaded traversal. The breadth first traversal is the method of traversing a binary tree level by level, starting from root node and move downwards. In each level, it is going to traverse from left to right. So here in this tree diagram, you can see several levels. So first, starting from root node. So the root node is going to be the 0th level in this tree. Then after that, we are going to increase each level number moving downwards. So first level is the root node which is 0th level. Then after that, children of the root node which is level 1. So how do we traverse that? So starting from root node, move downwards. In each node, in each level, traverse from left to right. So first, starting level is root node. We are going to write A, move down one level, left to right, B, C. Again move down to the next level, traverse from left to right, D, E. Move down one level, left to right, F. So that is the breadth first traversal. So we can do this breadth first traversal using a queue also. So how do we do this? We are going to use a queue to do this breadth first traversal. First, starting with an empty queue. Then I'm going to push the root node for this empty queue. Push root node is A. Then after that, I'm going to push the children of this root node, which is B and C. So the children are going to be pushed A, then B, then C. After that, I'm going to pop the front node. So the front node is A. I'm going to pop the front node and write the output here A, and the remaining in the queue is B and C. Then after that, we are going to do the same steps again. For B, pushing the children of the B node, which is D. So the queue is going to be B, C, children of the B. That's all the children of B node. Then going to pop the front node again, which is B. So the remaining is C and D. Write the pop node here, C, no, B. Then after that, pushing the children node of C, which is E. C, D, then E. That's all the children of the C node. After that, we are going to pop the front node again, which is C. Going to write it here. Remaining is going to be D and E. Then after that, the front node's children. Here D has no children, so we can pop it straight away. So going to pop the D node straight away since it has no children. So he is the only node going to be remain in this queue in this moment. Then after that, going to push the children of the E node. Which are F and G. Then going to pop the front node again, which is E. Then after that, by popping the remaining nodes F and G in the by front order, first it is going to be F, then it is going to be G. So here you can see, using a queue, we can also do the breadth-first traversal in the same way we wanted, which is A, first 0th level, then go to the level 1, BC from left to right, then go to second level, DE, then after that third level, FG. So that has been done using a queue. So up next, we are going to see the recursive versus iterative approach. I'm going to show that using an in-order traversal. So up next is recursive versus iterative approach. Uh, I'm going to explain this to you using a Java code. To explain this, I'm going to use the Inorder Traversal, which is best because it is easy to understand the logic and compare. So first, before going to recursive versus iterative functions, first we are going to define the node class, which contains a single node. Then after that, since I have not that much space to write the node class and the function, I'm going to first define the class, then we are going to move on to the recursive function, then the iterative function. Okay, so first going to define the node class. In this node class, it contains two attributes, which is a char type attribute called value and a node type attribute which is left and right. This contains the left node, which is the left child, and the right node, which is the right child. Then to initiate this, we are going to take a char value. Then that value is going to be used as this class value. Then we are going to add the initial state, both left and right childs are null. So then the class is defined. Then we will move on to the recursive function, how it will work, and after that the iterative function. Okay, so now is the recursive approach. Here you can see I'm going to use this function to implement the recursive approach. So in the recursive approach, we are going to use the same function again and again to call each node's left and right child. So first I will explain what this function does, then we will see how the Inorder recursive is going to be used to do the Inorder traversal on this tree diagram. So the name of the function is Inorder recursive. It is going to take a node type as an argument, checks whether that node is null. If not, then we are going to call the same function again for each node's left child. Here node.left is going to be used for the same function again. Then after doing that, we are going to print this node's value. After doing that, we are going to move to node.right, that means node's right child. So here you can see we have called the same function again for each node's left and right child. So we will see how this tree diagram is going to be implemented to show the Inorder traversal using this function. First I am going to take the root node, which is A, checks whether the node is null or not. It's not null. Then going to go to Inorder recursive node.left. So it is going to be B. So B is going to be taken into this function. In this function, here checks whether B is null or not. It is not null. It is going to go to that node's left child again, which is D. So that D is going to be again taken into the same function. Checks whether D is null. It is not null. Then going to D's left child, node.left. Here D doesn't have a children. So node.left is going to be null. So it is going to go back again. It is not equal null. No, it is null. Then we are going to go back again to D. We are going to print D's value, node.value, which is D. Then after doing that, we are going to go to D's right child. So here D doesn't have a right child. It is also going to be null. So checks whether the node is not null. It is null. Going to go back again. Then that function has been done for D. We are going to move again to B. Here after completing these functions we have moved to B. Then in this B nodes, first function has been done since we have moved to left child. Then we are going to print the second statement is printing the node value of this class node, which is B. Then after doing that, we are going to move to right child of B. We are going to take the node.write value to the same function again. So node.write, B's right node is E. Here B's right node is E. Then after that we are going to check whether E is null or not. E is not null. Then we are going to go to E's left child. E doesn't have a left child, it is going to be null. Then we are going to return. Then after that we are going to print E. Then after printing E, we are going to go back to E's right child. So E doesn't have a child, so E doesn't have a right child, so it is also going to be null. Then it is going to return again. Then after that we have completed E's subtree. Then we have completed B subtree. Then we are going to move to A, since we have completed this subtree. Then in the A, if subtree has been completed, we are going to print the number of this node, which is A. Then after that we are going to move to A's right subtree, which is C. So checks whether the A's right subtree is null or not. There is a value C, it is not null. Then going to go to C's left child, it is null, it is going to return again. Then it is going to print the current node value, which is C. So it is printing C. Then after printing C, it is going to go to C's right child. C doesn't have a right child, so it is also going to be null. It's going to return again. Then the function stops after outputting D, B, E, A, C. So here you can see it is in the Inorder traversal order. Here you can see first we are going to traverse through the left subtree, then print the node, then the right. Here D, after writing D, we are going to move to node B, then E, then after that completing left subtree, writing the node, then the right subtree. So it is the same as the Inorder traversal method. So that is recursive approach. Here you can see the system is the one keeping track of where we left off using a system call stack. So up next is iterative approach. Let's see how it is going to be different from the recursive approach. So up next is iterative approach. So before we saw how the recursive function worked, now here we will see how the iterative approach is going to fulfill the Inorder traversal. Here this is the function I used to do the Inorder traversal. First I will explain what this function does. Here we are going to take a node type as an argument, then we are going to use a stack to store these nodes. Here you can see we are going to take a stack. It is going to store node types. The name is stack of this stack. Then we are going to start this function using the root node as the current. Here you can see node current equals root. So that is the first current value of this function. So then we are going to go to a while loop. It is going to iterate until these both conditions become false. That is, there is no current value and also stack should also be empty. Then if not, we are going to go to the inner loop. That is going to check whether the current there is a current value. If there is a current value, we are going to push that current value into the stack. Then we are going to use that current value's left child as the new current value. Then after iterating through the values until the current value becomes null, then after that we are going to pop the current value, that is the leftmost child of this. Then we are going to print that value. Then we are going to move to the right child of this current value. So we will look at this tree. Here current equals root. So the right now the current value is a. Current value is a. I'm going to write the current value here for now. Stack is empty for now because there are no elements in this stack. Here stack is empty. Now while current not equals null, stack is empty. This is going to continue. Stack is empty, but there is a current value which is a. It is going to go into inner loop. Here, while current not equals null, current is not null, therefore it is going to push the current value, which is a. A is going to be pushed into the current value. Then after that, we are going to move to the current value's left child. So right now, current dot left, which is b, it is going to be the new current value. So new current value is going to be b. Then going to go to this while loop again. Current not equal null. Current is not null because it is b. It is also going to be pushed into the stack b. Then we are going to move again. Current dot left. So b's left child is d. It is going to be the new current. Checks whether current not equals null. It is not null. It is also going to be pushed into the stack. Then after that, current dot left. D doesn't have a left child, so this becomes null. Then this while loop stops. It is going to go to this statement. Current equals stack dot pop. So it is going to take out the topmost element from this stack. So it is going to remove D. D is going to be removed. Then we are going to print that value. D is going to be printed. So in the stack, D is going to be removed. Only A and B remain. Then after that, current equals current dot right. So right now the current value is B. So new current value is going to be current dot right. T doesn't have a right child, so it is going to be null. So it is going to go back to this while loop again. Then current not equals null. Current is null, but the stack is not empty. There are elements present in the stack. So it is going to go back into the this loop again. This is not going to be run because current is null. Then we are going to go back to this statement, current equals stack dot pop. So we are going to pop B also. B is also going to be removed, and that B is going to be printed B. So in the stack, B is removed. So new current is going to be current dot right. B is right child. There is a right child for B. So E is going to be the new current. E is going to be the new current. So it is going to go back to this while loop. Current not equals null. Current is not null. Also the stack is not empty. It is going to go to this while loop. Current not equals null. Check whether current is null or not. Current is not null because current value is E. It is going to be pushed into the stack. E is going to be pushed into the stack. Current dot left. E doesn't have a left child. So this while loop stops. the current value, which is E, is going to be popped from this stack, and it is going to be printed. So after that, E is going to be removed from the stack, only A remain. Then E is current dot write. E doesn't have a write child, so going to go back. Current value is null, but the stack is not empty. So what that does? Current is not is equal null. This doesn't go into run because there is no current value. Then we are going to go back to this statement, current equals stack dot pop. So A is also going to be popped here. Then it is going to print A. Then after that, current equals current dot write. So A's current value, so current value is right now A, current dot write. A's right child is C, so there is current value for A. There is a right child for A, which is going to be the new current value, that is C. So then going to go back while to this while loop. Current is not null because there is C. Then it is going to be pushed into the stack using this while loop. Here A has been removed from the stack. C is going to be pushed. Check whether C has a right child. C doesn't have a right child. While loop stops. Then the new current value is stack.pop. It is also C. So it is going to be popped from this stack. Then we are going to print that value C. Checks whether C have a right child. If, then we are going to iterate again. C doesn't have a right child. This loop stops. Then we are getting the Inorder traversal through this function here. D node left, then node, then right. Going to node again, then right subtree. Here you can see the code is a bit complex. That is because in the recursive approach we have used the system call stack to store the values, but in this we are manually storing the values using a stack. Then we will see what are the few differences between these two approaches. So now you know both recursive and iterative approach gives the same output but use different strategies. The recursive one is shorter and easier to write, but the iterative approach uses more code, but it is safer when we are traversing large trees. Here the differences. The recursive one uses a system call stack, but in the iterative approach we use the manual stack to store the nodes. Code simplicity wise, recursive one is simple since we doesn't have to manually push and pop the values to the stack. Iterative one takes more code and a bit complex. Memory control, in the memory control wise, recursive one has less control, iterative one has more control since we are manually controlling the stack. Recursive one is not good for large trees because it has the risk of stack overflow, but the iterative one is much safer for large tree traversal. Then we are going to see the different traversal techniques applications. Now we will see real-world applications of these traversals. Inorder traversal is commonly used for binary search trees. It is useful when you want to get the sorted order. It is also used in the expression trees, like converting between infix and postfix expressions in calculators. Preorder is useful when you want to save or clone a tree. It is also useful when you want to print the folder structure in a file system, because parent node is always going to be accessed first before the child node. Postorder is good when you want to delete a tree safely, because children nodes are deleted first before deleting the parent node. Level loader. It is useful when you want to process things step by step, like to find the shortest path in an unweighted graph, and in AI path finding, where in AI games where we simulate things step by step. So that is the real world applications of these traversals. Next, we will move on to the code implementations. Okay, now we will see how we can do the Java code implementation for preorder and postorder traversals, which is recursive approach and the iterative approach for both traversal methods. We have already discussed iterative versus recursive approach for Inorder traversal. First, I'm going to be explaining the Java code implementation for iterative preorder traversal. Then after that, I'm going to be moving to iterative postorder traversal code implementation. So first, iterative preorder. Here you can see the code implementation. I'm going to be taking the same tree diagram which I have used to explain the Inorder traversal. So first, this function is going to take the root node. The node class is same as the one we used in the Inorder traversal. So it is going to take the root node, checks if the root is null, and then we are going to exit this function. In this tree diagram, root is not null, which is going to be A. Then we are going to use a stack which stores node values. Then for that stack, we are going to push this root node. So for this stack here, this is the stack. We are going to push the root node, so it is going to be A in this stack. Then we are going to use a while loop to iterate through this until the stack becomes empty. So first, node current is going to be the value which is going to be popped from the stack. So the value that is going to be popped from this stack is A. Here this stack value A is going to be popped, and it is going to be used as the current node. Then after that, the stack becomes empty. Then we are going to print the current dot value. So current dot value is A. We are printing A. Then after that, here you can see we have pushed the right tree first. Why? Because in the stack, the element that is going to be added last is going to be processed first. So that's why we have pushed right first. So here, if current dot right not equal null, we are going to push that value to the stack. So here, for current value, we say current dot right value is going to be B. No, current dot right value is going to be C, and that is going to be pushed into the stack. C is going to be pushed to the stack. Then after that, current dot left. So A's left subtree child node is B. It is going to be pushed to the stack. Then going to go to the loop again. Stack is not empty. Going to go back again to the node current value. So the node current is going to be now the pop value from the stack, which is going to be B. It becomes the now current value. This is going to be pop. So in the stack only C remain, and we are going to print that value, which is B. Then after that, so we are going to go to the childrens of the B node. First we are going to go to right child of this B node, which is going to be E. We are going to push that value into the stack. Then after that, going to go to the left child of B node, which is going to be D. We are pushing that to the stack. Then checking whether the stack is empty again. It is not. Going to take the current value from the pop from going to take the current value, which is going to be the one popped from the stack, that is D. So now the current value is going to become D, and it is going to be printed, and D is removed from the stack. Then we are going to check whether D has child. D has right child and left child. D doesn't have a right child or left child, so there is no elements going to be pushed into this stack again. We are going to go back again, checks whether the stack is empty or not. It is not empty. We are going to go again. Going to take the current value as the one which is going to be popped from the stack, that is E. E is going to be popped, and the new current value is going to be E, and it is going to be printed. Then we are going to go to this if function, if and checks whether E have left child or right child. It doesn't have, so no elements is going to be pushed to the stack. Then check whether the stack is empty or not. It is not empty, C is still here. Then we are going to take the current value as the one that is going to be propped from the stack, which is C. So the new current value is C, and it is going to be printed, and the stack becomes empty. C doesn't have a left child or right child. Now elements is going to be pushed to the stack, so now the stack is empty. Then this while loop stops. Then here you can see we have gotten the nodes in the preorder traversal, which is going to be node, then go to left subtree, then the right subtree. So A, go to left, B is going to be printed, then go to left subtree again, D, then right, then we are going to go to A node's right subtree, which is C. So that is iterative preorder traversal. So then after that we are going to go to iterative post-order traversal. Alright, now we are going to move to iterative post-order traversal implementation using Java. Here you can see the code implementation. So to implement this function, we are going to be using two stacks. So first, for this function, we are going to take the root node as the argument. Root node is A. We are going to take that as the argument. Checks whether root value is null. It is not null. We are going to go downward, and we are going to create two stacks which are going to store node values. First one's name is stack 1. Second one's name is stack 2. Then we are going to push this root node into stack 1. So root node is going to be pushed into stack 1. Then after that we are going to use a while loop which is going to iterate until stack 1 becomes empty. So first we are going to pop the propend value from stack 1, and it is going to be used as the current value. So we are going to pop the value from stack 1. The value is going to be A. A is going to be popped from stack, and it is going to be the current value. Then after that we are going to push that value to stack 2. So A is going to be popped from stack 1. It is going to be pushed to stack 2. So stack 1 right now empty. Then after that we are going to check whether the current value has a left child. So right now the root node, if the root node has a left child or not. If it is having a left child, we are going to push that value into stack 1. So A has a left child, which is B. It is going to be pushed into stack 1. Then after that we are going to move to right child of A. It has a right child which is C. It is also going to be pushed to stack 1. So after that we are going to check whether stack 1 is empty again. It is not. So we are going to pop the value from stack 1. The value that is going to be popped from stack 1 is A, and it is going to be the now current value. This is going to be popped from stack, and it is going to be pushed into the stack 2, which is C. So C is going to be removed from stack 1. Then after that we are going to check whether C has a left child or right child. C doesn't have a left child, then it is null. There is nothing going to be pushed into stack 1. Then for right child, C doesn't have a right child, there is no element going to be pushed into stack 1. Then after that we are going to check whether the stack 1 is empty again. It is not. Then we are going to pop a value from stack 1, which is going to be B. So B is going to be popped from stack 1. It is going to be the new current value B. Then stack 1 becomes empty. It is going to be pushed to stack 2. Then after that we are going to move to left child of B. It has a left child which is D. It is going to be pushed to stack 1, which is D. Then after that we are going to be moving to right child of B. So right child is E. It is also going to be pushed to stack 1. Then after that stack 1 is still not empty. We are going to pop a value from stack 1. That is going to be the now current value, which is E, and pop from stack 1. It is going to be moved to stack 2. So E is removed from stack 1. Then after that we are going to check whether E has a left child or right child. It doesn't have a left child or right child. Nothing is going to be pushed to stack 1. Then after that we are going to again go back, check whether stack 1 is empty or not. It is not empty. It is still has D. Then we are going to pop the value from stack 1, which is D. D is going to be popped from stack 1 and move to stack 2. Now the current value is D. Then after that check whether D has a left child or right child. It doesn't have. So after that then we are going to check again. So now the stack is empty, since D doesn't have a left child or right child. So checks whether stack 1 is empty. It is empty, so this iteration stops. Then after that we are going to take out values from stack 2. So now we are going to take a while loop to check whether stack 2 is empty or not. We are going to iterate this until stack 2 becomes empty. So what we are going to do is we are going to print the stack 2's values. So we are going to stack 2.pop. So the values is going to be popped from the stack 2. So first one is D, then E, then B, then C, then A. So here you can see it has traversed in the Postorder method. First the left child, then the right child, then the node. So we have implemented iterative preorder traversal using Java also. Now we will see how these methods are gonna be running in the NetBeans IDE. So here I have used NetBeans IDE to implement this Java code. So first we will look at recursive preorder. Just like in Inorder, not much is going to be changed, just the way we are printing the values is going to be changed. So going to take the node. Well, first we are going to print this node. So why? Because in preorder, first we are going to access node, then after that we are going to move to left child, then after that we are going to move to right child. So in that way this is going to print in the preorder traversal method. Then after that we have discussed iterative approach for preorder traversal. Then the recursive postorder traversal, just like the way in Inorder, only the way we are printing the value is going to be changed. So in postorder, first we are going to move to left subtree, then we are going to move to right subtree, then after that we are going to be moving to node. So that's the recursive postorder. Then we have discussed iterative postorder. Then after that, level loader traversal using a queue. So the one we have discussed earlier. To implement it using Java code, here you can see the function name is level load traversal. We are going to take node root value, then check whether the root value is null. If then we are going to exit this function. For this we are going to be using a queue. The name of this queue is queue, which is going to store node values. Then we are going to add this root node into this queue. After that we are going to use a while loop. That while loop is going to run until this queue becomes empty. While it is not empty, first we are going to take the value in the front of this queue as the current value. Then we are going to print that value. Then after printing that value, we are going to move to that current node's left child, and we are going to add this to this queue. Then after that we are going to move to right child, then we are going to add this into this queue. So just like we have discussed earlier. Then after doing that, we can get this in the level loader traversal method. So here that simple tree I have created in this main function. So all these methods, all these traversal approaches we can see after I run this code. So here in the preorder recursive and the iterative, both the outputs are going to be same. Then after that, in the postorder recursive and the iterative approach, output are going to be same. Only the way we are implementing this is going to be changed. So in the level loader traversal, here you can see first we have taking care of the 0th level. Then after that moving down and traversing from each level to left to right, BC, then after that DE. So that is the Java code implementation. Alright everyone, that's it for this video. I hope you got a solid understanding about tree traversals, what are common type of tree traversals, iterative versus recursive approaches for them, and how we can use them in the real world scenarios, and how we can implement them in Java. Remember, choosing the right traversal method can make all the differences in your algorithm. If you found this video helpful, make sure to like and subscribe. If you got any questions or suggestions, drop them in the comments. Thanks for watching, and I will see you in the next video.